Well, hello. So I'm still one day behind. Today is December the 12th, and we're still on the 11th task. So one day behind. Hopefully today I'll be able to catch up. But hey, less talking, more doing. So for those who are new here, this is we're solving the Advent of Code challenge. We're doing one challenge every day. We're solving these in the programming language NIM. It's a new interesting programming language. Go to video 1 to check out why we're using NIM. Without any further ado, let's go to monkey in the middle. So we are in the jungle with the elves, and a bunch of monkeys has taken my backpack, and they've taken the items from there, and they are playing keep away with my items. And each item has a worry level associated to it. And the way this worry level is calculated is very, yeah, it's very particular. So when the game starts, each monkey gets some starting items. This is like the puzzle input. And then each monkey has this operation where they take the starting worry level of the item and they do some operation on it. For example, all times 19. Then they have a test whether this number is divisible by 23, so that is 79 times 19, is that divisible by 93? And then whether that is true or false determines to which monkey this item goes next. So we're playing this in rounds. So yeah, this is not per se very complicated, but it's a lot. And yeah, I misunderstood the rules of the game several times when doing this. So yeah, so that's what's gonna happen if you spend a long time on this. So let's take one example. This starts with monkey inspects an item with worry level of 79. This worry level is multiplied by 19, so now it's 1,000 and 1,501. So that happens. Monkey gets bored with the item. The worry level is divided by 3 to the closest integer. So now it's 500. Is this divisible by 23? Well, no. So then it is determined that it's not, so it's thrown to monkey 3. So my night vision goggles goes to monkey 3. Okay, and now let's not go through all of these examples, but let's see what happens when this item arrives at monkey 3 when it's monkey 3's turn. So it's exactly here. Yeah, monkey inspects an item with the worry level of 500. But now the worry level increases to 503 because if we inspect monkey 3's operation, it's old plus 3. So now this is actually 503. And let's also, divisible by 17, then it goes there and then it's go there. Okay, so here we are. Okay, monkey gets bored. Now it's again divided by 3 to the closest integer, which is 167. And then from that, is it divisible by 17 or not? No, which means that it's given to monkey 1. Let's select only those. And where is monkey 1? Okay, yeah, I indexed this wrong in the example. So monkey 1 would be monkey 2 exactly. So monkey 0, 1, 2. You get it. Indexing from 0 or 1 is a difficult task we developers have to deal with. So yeah, this is how these items get thrown around. So you can also see here, this is like the item that ended up with monkey 1 / monkey 2. And then what we're doing is we're playing this game for several rounds, throwing these items to each other, and then we have to calculate how many items the monkeys have during a game of 20 rounds. Okay, so confusing enough? Let's do it. So yeah, I'm gonna do this video a bit differently than the previous ones. I've actually now basically written a large part of the code already, and instead of like doing this live here, I'm just gonna go through it all, and then we're gonna see, basically we'll just play around with it a little bit, see how it works. So yeah, let's try this concept. So what I have is I have a separate monkey library, which contains all the nitty-gritty parts of how these monkeys work, how they update the items, and so on. And then we're going to have the actual game implemented in the AOC 11 file. And also one reason why I want to keep these in separate files is that the parsing of the input file is quite tedious. So maybe there's a more smooth way to do this. This is sort of like a straightforward, like just crunch it approach. So what we can do now is that we can, for example, say let monkeys parse. What did I call this actually? Parse monkeys. Like that, and then we can do for m in monkeys echo m. And of course I have to import monkeys. Let's see if we actually monkey, yeah. So there's no name collision going on. So yeah, this is what we would parse from the input file. So this is the initial state before the actual game begins. So monkey 0 has item with worry level 79, and now this is these are these worry levels. So only when the game starts, we start to calculate these like these additional stuff on the worry levels, and we're gonna do that with the function calc worry level item. So this is gonna do that all for us, and yeah, there's a reason I found this to be like the most smartest way to do it. So yeah, let's implement the game now. Let's see what happens. So yeah, this is how now you can see like the magic happening. So we start with an item of worry level 79, and then like it has worry level 500 after all the calculation has been done. And then we can also, let's see, echo, where is that? I had a function also for calculating, like, then based on, yeah, calc to whom, and that's m.calc item to whom, yeah, exactly. I'm just, yeah. And then we're passing the item, and we have to pass in an array for all the monkeys. So let's echo that as well. Yeah. So yeah, okay, it returns the monkey. So now we're echoing the monkey, which is, yeah, like this. We have to set it that m dot current items has to be an empty sequence, because the reason being that, because yeah, exactly, we have to empty its current items. It has gone through all of them, and we can't sort of like, if we do it in the loop while we are looping current items, we get like, yeah, I don't think that is even possible to do. So now we can just like at the end of, how should we do it? We were breaking there. Let's just echo m for, yeah, for m in monkeys. Echo m. Let's just see what happens after one round. Okay, yeah, so monkey 0 is without any items, as should be. Let's see, monkey, where did it give its items? So 500 is thrown to monkey 3. We can see that there. And also this one is thrown to monkey 3. So yeah, we can see that it worked like that. Nice. Let's take away that break. And now we are with one round finished, and we actually have a better table for that. So monkey 0 should have items with these worry levels. Yes, and that seems to be correct as well. Really nice, really nice. See, we're reading the correct input, and then we want to play for 20 rounds. And let's echo not that, but m.count. And let's see what happens. 20 rounds played. And what do we want? What is the... So we're calculating the monkey business score, which are the two highest multiplied together. Okay. So we have these are the highest. Let's just do like a quick, yeah, 280 times. These are the highest, right? I mean, we could check this quickly programmatically, but who has time for that? Submit. No, too low, too low. Damn. Yeah, really ironic that I said that who has time to do this programmatically when I'm not even able to do it manually, and I spend more time debugging my manual solution than I would have done programmed my correct solution. And there we go. So once again, never trust yourself, not even when it comes to counting simple, like which two numbers are there. Yeah, let's not. Okay, let's go to part 2. Yeah. Okay, so part B, we are no longer dividing by 3. So let's make that change here without breaking anything. So that should be the correct one. And then we are playing 1,000 rounds. So let's have a look at that. And then let's not calculate manually or look manually which is the highest. So let's see what we get. We get some problems. So part B was a lot trickier than I thought, and I went into the trap like a rookie cookie. So naively, I just went and deleted the like divided by 3 and just went into putting 10,000 rounds and yeah, let's just make it roll. This is gonna be easy. Not at all. So the problem was that here previously, or actually here, this is the problem, that the worry levels, when not divided by 3, became very, very large numbers, and especially here in the multiply, we were getting like an integer overflow. And of course, my natural instinct was to, hey, we just need bigger integers, we need more bytes. So I went and checked, and there's actually a big int library for nim that you can install with the package, like nim's package manager called Nimble. I did that. It kind of worked, but it took like, I don't know, 500 rounds took maybe 5 minutes to do. So yeah, you do the math how long processing 10,000 rounds is gonna take. So that's obviously not the solution. So yeah, after a little bit of Googling, I actually think that this is the way to go. So what we need a way of scaling the worry levels down without them. So what are the worry levels actually used for? They're used for determining to which monkey the item is sent next. So we still need this to sort of like work with the same logic, that the worry level modulo the divisor should still like hold true and false for the like correct, even though if we scale it. So now the question is, how can we scale the worry level for different divisors? So the thing, what I found online, I'm not sure if this is called like the Chinese remainder theorem, but I think that's like at least a like an adjacent problem. So what we use is we use the least common multiplier. So it's imported from the math LCM. And from there we get like the least common multiplier for all the divisors that we have, and then we take like what comes ever from this operation, and we take modulo the least common multiplier, and we set that to the worry level. So now I've cleaned it up a bit so that we take in the divisors more like programmatically, and then here also let's do echo res, and we want to take there's actually a very Python-like operator we can do like this, which means the last two items in the thingy in the array. So, and now we have test, and we want to take the input, and now the moment of truth. 10,000 rounds is going, and yeah, these are the results, and this would be the final answer. And yes, after struggle, after some, maybe a lot struggle, we finally got it. So, okay, apparently now these are getting a bit more tricky, so we have to do all these kinds of least common divisor tricks and stuff like that. That's these are becoming a bit more harder, I have to say. But one nice thing was today to find the big ints library in nim, and yeah, I don't actually, or do I have it? No, I don't have it. Oh yeah, here. So it's not by default something that you have. Here's the GitHub, and you can just nimble install, and then you're able to use this. So this is how you would use like packages in nim if you install them from online. Otherwise, pretty standard stuff. And let's get on with the next one.